Hello friends, welcome to Prismatics online class. In our today's class, we are going to look at what we call mathematical induction. Mathematical induction. Okay, now let's look at what the principle of mathematical induction. The principle of mathematical induction. Okay, let's go. Suppose P of n is a statement involving the positive integer n or natural number. Then suppose that the following three conditions are satisfied. A. P of n is true. That is, the statement is true for n equals to 1. That is the condition. P of n. The P of 1 is true. That is, the following the statements for n equals to 1 is also true. Okay. 2, that is B. Assume that the statement is true for n equal to k. That is, P of k is equal to 2. If the statement is true for n equal to k, it means that automatically that P of k is true. Okay. 3, C, which is if the statement is true for n equals to k plus 1, then the P of k plus 1 is true for all positive integer n, or for all natural numbers, anyone. So if it is true, if the statement n equals to k plus 1 is true, automatically P of k plus 1 is also true for all positive integer n, or you can say natural number. Okay, so the definition of mathematical induction involve all. So suppose you state this to the end, and that is the definition what mathematical induction is all about. Okay, I hope you are following. Okay, thank you. Now let's look at the method to solve mathematical induction. We have almost 3 methods, 3 patterns, 3 steps that we must follow to solve mathematical induction. First is what we call basic step. That basic step is where you are going to test for P, or you are going to test when n is equal to 1. If n is equal to 1, if it is true for n is equal to 1, it is automatically true. So now look at this. We are going to prove that P of 1 is true. That is, that P of n is true for n equals to 1. First of all, you test when n is equals to 1. Is it true? If it is true, it means that P of n is true. Or P of 1 is true. Okay. Second step in solving mathematical induction is what we call the inductive step. In this inductive step, we assume that P of k is true when P of n is true for n equals to k. Now, first of all, when you test for P of n, that is when n equals to 1 and it's true, you now go to P of k. That is when n equals to k. You test it. If it is true, now the inductive step is also true. That is that P of k is also true. Now, if P of k is true, you now go to what we call inductive hypothesis. That is where you are going to test for where you are going to test for P of k plus 1. If P of k plus 1 is true, that is the statement for n equals to k plus 1 is also true. So you need to check whether the P of k is true for the statement whenever n is equal to k plus 1. So what are we going to test for this place? The step are we using for this mathematical induction? First step is what we called basic step. After basic step, that is when you are going to test for n equals to 1. 2, we are going to look at what we call inductive step. That is where you are going to check for n equals to k. 3, you are going to go for what we call inductive hypothesis. That is where you are going to test for n equals to k plus 1. So 3 steps you must test. You must check when n equals to 1, That is the first step. After then, you check when n equal to what? K. And finally, you now check when n equal to k plus 1. This is almost 3 steps that you are going to follow to solve what? To solve mathematical induction. And if all these things true, you can now conclude. Hence, if p of 1 is true, p of k is true, and p of k plus 1 is true, that means the statement is also what? True. That is how to solve it. Okay, now let's look at application of mathematical induction. Where do we apply mathematical induction? Now, first, it is used to generate the electricity that powers calculators. Mathematical induction is used to generate electricity that powers what? Calculators. 2, it is used to prove general structures such as trees, termed as structural induction. Okay. 3, it is used for computer science like recursion. That is where we applied mathematical induction. We use it in what? Computer science, something like what? Recursion. 4, it is used for correctness proof for programs in computer science. Okay. 5, family trees. This shows the numbers of offspring in each generation. This shows the number of what? Offspring in each generation. To generate this, we use mathematical induction. We use mathematical induction to generate what? The number of offspring in what? Each generation. That means we apply this mathematical induction in what? Biology. So it is applicable in what? Biology. Now also we use mathematical induction to solve problem in what? In numerical analysis. We also use mathematical induction to solve problem in what we call differential equations. So we apply mathematical induction in some of other things that in life. We apply it in other fields. Remember that you need to know the definition of mathematical induction, that is the principle of mathematical induction, the step to solve what, method to solve what, the method of solving what? Mathematical induction, the application of what? Mathematical induction. That is all about mathematical induction. Remember that mathematical induction, you are going to look at what? The three cases. Case 1 is when you are going to test for p of what? 1. That is when n is equal to 1. 2, you test for what? P of what? K. That is when n equals to what? K. Finally, you now test for p of k plus 1. That is when n equals to what? K plus 1. If it is true, you can now say hence p of 1, p of 2, p of 1 and p of 1, comma, p of k and p of k plus 1 is true for all positive integer, or you say natural number. That is all about mathematical induction. So in our next class, we are going to solve questions whereby we are going to state them step by step to prove whether the mathematical induction hold on a particular problems, or whether mathematical induction does not hold on a particular question or problem. So thanks and God bless you. Remember to subscribe to my YouTube channel, Prismatics Online Class, and follow me on Facebook, the same Prismatics Online Class. Please like, share, and comment. Bye.